Good evening, students. This is Jared. We're back again, and this week I'm going to go yet again show y'all some of the homework problems y'all have to do and kind of give you my way of how I would approach the problem. So just kick back, relax, and enjoy your assistance. All right, let's get started. First problem deals with the parallel lines, where we have two parallel lines here, and we have a transversal that runs through both lines, and you're given two angles, angles A and B. Angle A is 63 degrees, angle B is 61 degrees. And based on that, we want to find the other 12 angles that are going to be here in lines 1 and 2. So here are the 12 angles. Now, with that in mind, how would you find these angles? Well, first of all, let's start by remembering one thing, is that if there's an angle adjacent to it, like on the other side, it is considered a similar angle. They will have the same angles. As a result, we know that for angle A is 63 degrees, angle 2 is adjacent to that, and that is 63 degrees. Likewise, angle B has 61 degrees, which means since angle 9 is adjacent to it, that will also be 61 degrees. Now, when you have a line, you know a half of a line going from, let me get my pointer out. Going from, say you're here at the top of the line, this just means that this angle is going to be 180 degrees. So we call that a supplementary angle, and we know that angle 6 is going to be x, if x were, let's say, 61 plus x equals 180, then that will give you your angle 6. So we have 180 degrees, take away 61. That gives us an angle of 119. And since they're adjacent to each other, similar angles yet again. Now, we have our angles here, 61 and 61. Since there is this transversal line, these angles also apply to the other parallel lines. So the 61 degree angles are also going to apply to angles 3 and 4. So going back to what I said earlier about the 180 degree supplementary angles, we can now solve that here for angles 1 and 5 here in line 1. So 63 and 61 is 124. 124 plus x is 180. That leaves us with 56 degrees. And then here we are. Well, we can apply this, since this is on a transversal line as well, going to the other side of line 2. We could take the two 56 degree angles and put them here in angles 7 and angles 12. And then for one last time, we just got to solve for 180 degrees to get supplementary angles. 180 minus 50 is 130. Take away 6 is 124. And just like that, you have your angles. Oh, and if y'all forget about it, here's a chart for you that kind of explains how they all line up. Now, I have complementary here, and that's when angles add up to 90 degrees, but it didn't work in this scenario, but I just want y'all to be aware of it. Now, on to the next problem. That has to do with our triangle, so we're still kind of working with angles here a bit, but it's a little different. Instead of lines, we're actually working with a triangle, and in this triangle, we have 8 angles that we are looking for. And we also have 2 angles that we are already given. 74 degrees, and what is angle C? Angle B is 26 degrees. And we also have a little line here in red that gives us PQR. Now with that in mind, we want to solve for the 8 angles. So first of all, let's start here. We know that all 3 angles in a triangle have to add up to 108 degrees. Since angle 1 is a part of ABC, we can just solve for x. 74 plus 26 is 100. That leaves only 80 degrees to give us angle 1. So angle 1 is 80 degrees. Now, with that in mind, there's other pieces of information that you can use. Now, angles 3 and 8 do correspond, so they are also one at 80 degrees. and then 3 and 5 form your interior angles, and that makes angle 5 80 degrees. So just like that, using your knowledge of supplementary and complementary angles, you already know half of your angles. Now, remember when I talked about supplementary angles and how they're on the parallel line? That applies here too, because angles 2 and 3, they're on a line and it is not curved. So we can apply that theory. So we'll take 80 degrees. We already know that angle 3 is 80 degrees. So take away that, and we have angle 2 being 100 degrees. And then we just use that knowledge to find our last 3 sets of angles. And I have that listed for you here on the slides. And once again, I also have a chart, once again, explaining how the angles all relate to each other. So if you get confused, you can always refer back to this. Now, moving right along, for our third question, we have the concave polygon. And that is the polygon where we have variables representing each interior angle ranging from 3y to 12y. First, this deals with interior angles, so we have a total of 8 sides here. The official formula for that is n-2 times 180. So we have 8 sides, 8 represents n, 8 minus 2 is 6, and then we multiply 6 by 180 to get 1080 degrees. With that in mind, we now focus onto the next part. We want to try to figure out what y is, and we have enough to solve for y. We start off by adding all of the y variables to get 54y, and then divide both sides by 54 to get our final answer. And now we find out that y is equal to 20. Now, with that in mind, all you have to do is just plug in 20 for y and do the multiplication, and you get the final answers right here. That's what the math comes out to. For number 4, we're working with interior angles and exterior angles. So for interior angles, that deals with, once again, the insides. We have n-2 times 180, once again, like we worked with on the last problem, except we want to find out there's only one side that we want to find out. Since they're all the same, we're going to take our total number of degrees, which is 1,260, divide that by the number of sides to get our final answer, which is 140 degrees for the interior angle. Now for exterior and central angles, we have 300. Now, the formula for an exterior and central angle is much easier. The formula is simply 360 over n for n, a polygon with n sides. So all we have to do is plug in 9, and we get 40 degrees of exterior and central angles. Now, the thing you also want to realize is that these angles do add up to 180 degrees. All right, for our penmulet question, number 5, this is about creating the cube and creating the tetrahedrons in here. Now, I understand I had a little bit of trouble with this myself, so sometimes just getting your cube right to look like this can be a challenge. And thankfully, with technology, you can kind of just get your lines up straight, and it's pretty easy to make a cube. Now the goal here is to kind of make the goal here is that you're kind of making triangles. With our first tetrahedron, we're just making a single triangle, just a simple line just going from one vertex to the other. And this one, the second one, is where you'll have the multiple dimensions and you'll have the multiple vertices working together to give this triangle other dimensions. Like, see how you can kind of visualize here multiple faces? That's the goal you want with the second one. The first one, just having the one singular face, it's fine, but with this one, with the second one, I'm looking to see that you can give in multiple dimensions to let you see individual faces. And finally, creating with Schedul's module, I can. It's basically you have three sets of hedron. You have the tetra, octo, and isohedrons, and basically what you're doing is creating sets of triangles that are based. That you're creating a triangle that's built from multiple triangles, like the tetrahedron. It's a four-faced. Excuse me. The tetrahedron is a four-faced triangle. So you would create you would think you'd create a triangle from four, right? No, because the ultimate product you make is a triangle of itself. So you have to subtract that one triangle. So four faces minus the one that's going to come from the final product, which is a triangle in itself, and you're going to create a triangle with three faces. You also repeat that here with octo. A triangle with 8 faces. You gotta take away one for the face, because it's like you're creating a whole face, and there's only going to be 7 because the entire figure is a triangle. And then with the isohedron is a 20-faced polygon. Yeah, it may come out messy, but I promise you, it's gonna be okay. As long as you can show me the different individual triangles, I will not be too picky, because that would not look good on my end, because you can see how well this went for me. Alrighty, that does it for me today. Thank y'all for tuning in, and let me know if y'all have questions, and I will get to them next time. So, have a good week.